Assalamualaikum and hi everyone. Welcome back to Computer Science lecture number 2. I'm going to explain to you about number conversion. We are still in topic 1, system concept, and subtopic 1.2, number system and representation. So here we still have 3 learning outcomes to cover. All of them are to convert between numbers. We have 3 numbers that we cover in this course, that is binary numbers, decimal numbers and hexadecimal numbers. So I'm going to explain to you in my approach. I'm going to explain to you in this sequence. Okay, meaning I'm going to explain to you from decimal to other base first. Okay, so the first one is decimal to binary, and then decimal to hexadecimal. Next, I'm going to explain to you from other base, from binary and hexadecimal to decimal. Okay, and then I'm going to explain from binary to hexadecimal and from hexadecimal to binary. I hope you will have no problem with this, because this is a little bit, the sequence I mean is a little bit different than what you have in the notes. But I believe you can find your way in the notes, okay? Okay, the first one is conversion from decimal to binary and hexadecimal. So we have one common rule here, which is whenever we convert from decimal to other bases, the process we have to use is we have to divide. We have to divide the given number, the decimal number, by the base of the destination number. For example, if we are converting from decimal to binary, we are going to divide the number given to us by 2. Okay, and similarly, if we have to convert from decimal to hexadecimal, we are going to divide the given number by 16. So let's look at the steps first. From decimal to binary, the steps are like this. Okay, we have to repeatedly divide the given decimal number by 2. This is we are going to do a long division, and then you have to write the remainder at the right side, and then you have to combine all the remainders and take them as the answer. So and the way to take the answer is we are going to take from the last remainder to the first remainder. So this is an example to convert a decimal number to binary. We are given 38. Okay, this is 38 base 10, or decimal number 38. So this is the way we are going to do it. Number 38. Okay, and then you're going to draw it like this, divide by 2. Okay, and then we are going to have 19, right? 2 times 19 is 38, so we have no remainder. You have to write the remainder here. Okay? 0, you still have to write. Even though there is no remainder, you have to write 0. And then keep on dividing. 19 divided by 2 is 9. 2 times 9 is 18, meaning we have 1 remainder. And then 19 divided by 2 is 4. Meaning we have 1 remainder, because 2 times 4 is 8. We have 1 remainder. 4 divided by 2 is 2. No remainder. 2 divided by 2 is 1. No remainder. And 1 divided by 2, we cannot divide it because 1 is smaller than 2. So the answer is 0. And the 1 is going to become a remainder. Okay, the thing that you have to note here is we have to keep on dividing until we get 0 in the last row, right? Keep on dividing until the last one is 0. So when that is done, meaning we have the answer now, you're going to take from the bottom up all the remainders. You have to combine that, meaning the answer is 100,110. Hence 38 base 10 is equal to 100,110. Okay, I hope you can follow that. This is quite easy actually, because maybe you have learned it in school already. Now the next thing is to convert from decimal to hexadecimal. The step is quite similar, okay, because the first thing is you have to repeatedly divide the given decimal number by 16. Why by 16? Because you are going to, the destination base is hexadecimal. So, and then the second step is the same. You have to write the remainder at the right side, and then you have to combine the remainders as the answer, taking from the last remainder to the first remainder. Let's look at the example. We have the decimal number now is 1341. To convert to hexadecimal number, so we are going to write like this: 1341 divide by 16, and then of course this one you have to press the calculator, or you have to type in the calculator. You have to calculate it using calculator. When you take 1341 divide by 16, you are going to have 83 point something. We are not going to take that decimal points here, because we are doing long division. So you just take the whole number in front of the answer just now, 83, and then what you're going to do is you have to times 83 by 16, and then you will get something, okay, and then you have to minus that something from 1341. That is the remainder. Alright, so meaning we are going to get 83. 1341 divided by 16, we have 83 with the remainder 13. Make sure the remainder here is less than 16, right? It should be less than 16. If not, there's something problem, right? So keep on dividing with 16. 83 divided by 16 is 5, right? 16 times 5 is 80, so the 3 becomes the remainder. 5 divided by 16, because we cannot divide it, because when a smaller number divide by a bigger number, it's going to have 0 right in front on the top of the division. So we have to write 0, and this 5 is going to become the remainder. Okay, then when you see you have 0 here, we have reached 0 in the last row, it means your division process is complete. Now you are going to take these remainders as the answer. We have the answer already. Make sure you take from the last remainder, or the bottom one up. So we have 5, 3, 13 as the answer. But remember to change any number above 9, meaning 10, 11, 12, 13, 14, 15. Make sure you change that to the correct symbol in hexadecimal number. As we have seen earlier, 10 is represented by A, right? 11 is represented by B, 12 C, 13 is D. So the answer now is 5, 3, D. Okay, make sure you write this part. This is important. This is your conclusion of what you have done here. In the exam, you have to show these workings, and also you have to write this answer, right? And about this base, do we have to write the base? Okay, this is something which is optional, but I suggest strongly that you write the base, because this is going to make your answer more perfect. Alright, let's proceed to the next conversion. We are going to look at a conversion from other base. Here we have binary and hexadecimal to decimal. Okay, there is also a common rule here. When we convert from other base to decimal, we are going to multiply the given number, each digit in the given number, by the place value of the given number, the given base. Okay, for example, if the number is binary, each digit in that binary number, you are going to multiply with the base, the place value of base of binary. So maybe this is going to be clearer when we look at the example later. Now this is the steps. Okay, let's look at the steps first. 2 steps only. First step is you have to multiply each binary digit with its place value to get the digit value, and then you have to sum all the digit values to get the answer or the decimal value. We are going to decimal. Okay, if you look here, we are going from binary to decimal, so we have to multiply and sum all of it to get the decimal value. So one thing that we have to take note here, the place values of binary numbers, 2 to the power of 0 starting from starting from right, 2 to the power of 0, 2 to the power of 1, and onwards. Alright, so actually the value 2 to the power of 0 is 1, 2 to the power of 2, 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8. You can use either 2 to the power of something like above, or you can immediately use directly use 1, 2, 4, 8 is alright. Right? Okay. This is an example. Convert binary number 10110 to decimal number. Okay. Now we write like this. Okay. Don't draw any table for this one. I would prefer you do like this. This is, I think, is easier to see what you are doing. So you are going to take the last digit, multiply by 2 to the power of 0. The second last, multiply by 2 to the power of 1. The third last one, multiply by 2 to the power of 2. And then 0 here, multiply by 2 to the power of 3. And 1 multiply by 2 to the power of 4. Right? And then solve that. And then sum all that, and we are going to have 22 base 10. Hence the answer is like this. Okay, next, hexadecimal to decimal. We are moving from base hexadecimal to decimal, still in this the going to decimal. The steps now is quite similar than from binary to decimal. Multiply, that is, you are going to multiply each hexadecimal digit. This is the given number that we have to convert. You have to multiply each hexadecimal digit with its place value to get the digit value, and then sum all the digit values to get the decimal value. Alright, so the place values of hexadecimal numbers, of course, we have to write its base 16. 16, how do we know? It's hexadecimal, right? So hexadecimal is base 16, so 16 to the power of 0, 16 to the power of 1, 16 to the power of 2, and onwards. Here's the example. Convert AFB2 base 16 to decimal number. So solution, AFB2, the last digit here 2 is going to multiply by 16 times 0. The second from last B is multiplied by 16 to the power of 1. F multiply with 16 to the power of 2, and A is multiplied with 16 to the power of 3. And now we are going to convert. If we have letters like this, make sure convert it correctly. Yeah? Okay, so make sure A is 10, F is 15, B is 11, and then you just multiply with this. This is to the power of, right? Not 16 times 3. This is 16 to the power of 3 is going to be 4096. F is 15 times 16 times 3 to 56. 11 times 16, 2 times 1. Make sure 16 times 0 is 1. Anything to the power of 0 is 1. Not times, to the power of 0. So make sure you do this correctly. Don't do any careless mistake. And then solve all that, evaluate that, and sum all that. We are going to have quite a big number here. So this is the answer. Right? I hope you understand. I hope you can still follow this. We have 2 more